In section 1.4, we talked about linear models. And then in section 1.5, we talked about exponential models. 1.6 was actually an example or an application of exponential models. But in 1.8, we're going back to sort of learning about, again, another model. So we've done linear, we've done exponential, and in 1.8, we're going to do logarithmic. A logarithmic equation, which is denoted ln reg in your calculator, is f of x equals a plus b natural log x. Ln is natural log. That's where that's coming from. Really important note here. For logarithmic models, you cannot use inputs that are less than or equal to 0. If you try natural log 0 in your calculator, it'll say domain error or input error or something like that. If you put in a negative, natural log negative 2, same thing. It's going to tell you there's a domain error or an input error. There are actually two graphs possible, much like with exponential, that we can see for a logarithmic model. This is one. This happens when that b value that is listed above is actually greater than 0. And we would say, based on what we've done before, that this is concave down. And then our other model that could show up is sort of flipping this along or over the x-axis. This is what this looks like when the b is negative. And this is a concave up graph. Once you have that drawn, go ahead and get out your calculator. I would advise you to have out with you maybe those notes from 1.4 with all those regression steps. There's like a whole page of steps, until you get to the point where you feel comfortable and you sort of have innately learned them and don't need that. But we're going to use them here on the next example. So this is our peach consumption. Ariel, this is that same one. This is the same table as the one that you had talked about in your questions that you had. Well, at least it's the same peaches. The average yearly peach consumption per person based on yearly income when peaches are $1.50 per pound is given by the table below. Yearly income, tens of thousands of dollars. So this dark green line at the top says the 1 means I make $10,000 a year, the 2 means I make $20,000 a year, the 3 means I make $30,000 a year. Do you understand what the inputs are meaning? Okay. The second part tells you how many pounds in a given year that person ate of peaches on average. So in that first one, they ate 5 pounds of peaches in a given year. The second one, they ate 6.4 pounds of peaches in a given year. The third one was 7.2 pounds of peaches, and so on. Okay? So as you're looking at this, what you should notice is that the more money you make, the more peaches you eat. That's what that's saying, right? It has to do with expendable income, right? I mean, like, that's the idea. If you had more expendable income, you might have more variety of what you're eating. The question asks, though, why is the graph not linear or exponential? And to do that, the easiest way to answer that question is to actually look at a scatter plot. So go ahead and grab your calculator out, stat edit, and we're going to enter 1 through 6 in L1. So this is L1, and then the 5.0 through 8.6 in L2. Once they're in your stat menu, if you will press Y equals, you can turn plot 1 back on if you turn it off before. I did. And then do zoom 9. That's your zoom stat menu. And I suspect you're going to get a bunch of dots that look something like this. Do your dots look kind of like that? Okay, so let's answer the question they asked, which is, why is it not linear or exponential? Why is it not linear? It's not a straight line. Pretty obvious on that one, right? It's not straight. So it's not linear because it's not straight. Why is it not exponential? Do you remember what the exponential graphs looked like? Yep, Martin. Or decrease, right? Yeah. So they actually had image-wise one of these images. They either looked like this or like this, right? What can you tell me about concavity of both those graphs? They're both concave up. What's the concavity of my white dots on my screen? Concave down. So it's concave down. Not up. If it's not concave up, then it's not exponential. Just like if it's not straight, it's not linear. Make sense? This data simply doesn't fit one of those models. But it does want us to actually find a logarithmic model. So you've got the dots already in your calculator. So you've done part of the work to do that already. If you'll just go back to your regular screen in your calculator and go back to the Stat menu, Stat Calc, you can arrow down until you find the one that says LN-Reg. And it's option number 9. LN-Reg. Okay, we've done linear regression, exponential regression, now natural log regression. And if we use that one, make sure you're storing it inside of Y1. I would encourage you to go ahead and graph it so that you can see that it fits like you're expecting. Well, we're going to write it to 3 decimal places in a moment. So did your graph actually come over here, so to speak, and like connect the dots pretty well? Does that look like what you have? Nope. Okay, let me see what you have then, Sarah.
You go to Stat Calculator. LN-Reg.
Did you do LN-Reg or LN-Reg?
LN-Reg.
Number 8 or 9?
9.
Very good.
Then I got here.
Okay, go down to your store regression equation and call it Y1.
Just say Y1.
Yep. Vars.
Oh, Lord.
Yep. Y vars function Y1. And then go down one more and hit calculate. Yep. Hit the graph and it should show it now.
Okay.
Fabulous. Does anybody else does not look right? Okay. So if you hit Y equals now, you can actually see it having plugged in the values in the appropriate locations to be able to write your equation on part B. Your equation needs a name. I'm going to call mine P of X because we're talking about peaches. In my screen, it has 5.005 if I use 3 decimal places, plus 2.002 natural log X. Does yours look like that? Good. Have we finished our model? Nope. Every time we do a model, it needs language surrounding it, right? Got to have a name, got to have an equation. We've got those things so far. And you get all the units from the table. So we're going to write down, this gives me pounds per person per year. Of peaches. Where X is, how does it say it? Yearly income in tens of thousands of dollars. Okay, output first, input second, and then the interval. My interval went from 1 to 6. Okay, any questions on the model? Did everybody's model give them those values? Okay, good deal. So if you take a look then at part C, it wants us to estimate the consumption of peaches if you make $35,000 per year. So for a general person making $35,000 per year, about how many pounds of peaches per year do they eat? Okay, well, my equation, I called it P of something. For 35,000, what number will I input into my equation? 3.5, right. And this is why that input interval, not input interval, but the input description is so important. I need to enter this in tens of thousands of dollars. It's 3.5 tens of thousands of dollars. So if I plug this into your calculator, you can do that into your table and just type in 3.5. It will spit out at you 7.513 with 3 decimal places. Pounds per person per year. Part D, according to the model, when will we consume 10 pounds per person per year? So we need our model, P of X, to equal 10 pounds per person per year. Now, there's not a table way to do that, right? I wish there really were. That would be so nice if I could just put 10 into the Y column. I can't do that. But my equation is already in Y1. And I can put 10 in Y2. And I could look for them to intersect. Probably you're going to have to zoom your screen out a little bit. Just one time on mine was enough. And I did see it cross. It looks like this eventually. And I'm looking for that intersection spot. Second trace, number 5 for intersect. Press enter 3 times. And when I do that, it yields that the X value equals 12.124. Okay, take a look. Yep. You typed and you raise it in, but it isn't exact. When you have it exact, it has all those numbers that are automatically. So when you get that to happen, is when you do that step how much money per year does that 12.124 represent that somebody made?
12,124.
Nope, but that's a really good guess. Remember it said it was in tens of thousands? Mm-hmm. Yeah, tens of thousands would mean I would take that number and multiply it by 10,000. So it'd be 121,240, approximately. All right, let's move through the last parts very quickly. We aren't going to end up with quite as much time as I had hoped. We're going to cut it quite close. I'm so sorry. It says to interchange the inputs and outputs in the table and write a model for the inverted data. So I'd like for you to go into your stat menu, so stat edit. And what you're going to do is you're going to actually put L1 as the peach consumptions and L2 as the yearly income. Okay? So you're going to do the 5, the 6.4.
So you just switch them?
Yep, you're just switching them. 7.2, 7.8, 8.2, and 8.6. And then 1 to 6. I'd hit y equals, clear out the equations that are in there so that you don't end up with random equations showing up on your screen. And then just zoom 9 for zoom stat. And you should see a bunch of dots that look something like this. Maybe not quite that drastic at the end, but approximately so. Do your dots look like that? What kind of an equation would those dots most likely represent? Not linear.
No.
Exponential. Looks exponential. So if you hit stat, calc, option 0, which is exponential regression, and put it into y1, the equation that you will get, I'll call mine f of x, is 0.082 times 1.648 to the x.
On stat calc, which one are we putting in?
EXP-REG, it's option 0, exponential regression. So this is what the equation looks like. It does want a model. So we already did the model over here, and we just switched the inputs and outputs, so we just switched the x and y, or the input and output descriptions. So over here, this is going to say tens of thousands of dollars. Of income. When a person I'm going to say eats, consumes is too long, eats X pounds of peaches per year. This time, it was actually 5 less than or equal to X less than or equal to 8.6 as my input interval. People do this all the time. This equation makes it actually feel like that if you eat more peaches, you're going to make some more money in a year. Doesn't it? Yes, it does. You just watch all the things going on in your world right now that people are trying to tell you to do something like this. We can create an equation. It doesn't mean it's cause and effect. We have one more example to do. Any questions on this one before I switch screens, though? Okay. We've got a mouse. This mouse shows up in different sections in our book. I don't know why. The mouse is so exciting, but he shows up several times. The table gives the body weight of mice used in a drug experiment as recorded by the researcher. We've got their age, 3, 5, 7, 9, 11. We've got their weight, 11, 20, 23, 26, and 27. These are in grams. It says to find a model for a mouse's weight, G, in terms of its age, A plus 2 weeks. And I do this one for example because when it shows up, you're limited in what the examples are that the book actually will give you questions for. It tells you to align the age by subtracting 2 from each entry. That's what that A plus 2 part is telling you. So when I put the age in here, this is going to be inputted as 1, 3, 5, 7, and 9. Okay? So in your calculator, stat edit, we're going to enter 1, 3, 5, 7, and 9.
And the weight's going to stay the same.
And Y2 or L2 is going to stay the same. Yes, these are L1s, and this will be L2, the weights. Mark, this is kind of like the question that you had on the homework last time where they were telling you to align it to the year 17 because it would actually end up fitting the graph better, or the graph would fit the data better if it were aligned in that specific way. Same idea here. All right, if you clear out Y equals and do zoom fit, you'll end up with dots that are much like we've seen on the previous problem. Something like this. It's a log graph. So we do stat, calc. It's option 9, ln reg, not ln reg. Make sure you tell it to go into Y equals. I'll call mine M of X since we're dealing with the mouse. And we get 11.298 plus 7.372 natural log of X. And then we can do our input-output information based on these. So the output is in grams. And this is for a mouse that is not A because we're using X, so X plus 2 weeks old.
So because we're looking
You're right. That's exactly what we're going to do. One more thing here. Make sure you put that this is 1 less than or equal to X less than or equal to 9 as the last part of your model. Yeah. And then Mark's exactly right. Since it wants to know about the mouse that weighs, or that's 4 weeks old, you can see what would happen sort of from our chart right here. Here's 4 weeks, right? It's in between 3 and 5. We take away 2 from it. It would be finding the value at 2. So I would have my mouse, M of 2. And if I plug that into my table, it tells me it's 16.408 grams. Okay? Wonderful. Alrighty then, we have finished now these 2 sections. I know it's a whirlwind. I promise it'll slow down eventually, but these 2 lessons will be due next class period. Bring any questions you have, if there's not too many of them, or come see me or Katie and touch base, get some help, those kinds of things. We'll see you guys on Thursday.